In the aftermath of the devastating floods that ravaged Dubai and the United Arab Emirates, leaving a trail of destruction and claiming lives, a heated debate has emerged. As the nation grapples with the unprecedented rainfall and the resulting chaos, many are pointing fingers at the country's long-standing cloud seeding program, questioning whether this weather modification technique played a role in the catastrophic events. Amidst the swirling speculation and viral social media posts, it is crucial to separate fact from fiction and seek the insights of experts in the field. Join Viewcation as we dive deep into the controversy and ask the burning question. Experts speak out. Is cloud seeding to blame for deadly floods? What is cloud seeding and how does it work? Cloud seeding, a form of weather modification, has captured the imagination of scientists and the public alike since its inception in the 1940s. This intriguing process involves artificially stimulating clouds to produce rain or snow, offering a tantalizing possibility of influencing the weather itself. But how exactly does cloud seeding work, and what are the principles behind this fascinating technology? At its core, cloud seeding seeks to replicate and enhance the natural process of precipitation. In the atmosphere, tiny water droplets form around particles like dust, salt, or pollen, gradually growing until they become heavy enough to fall as rain or snow. Cloud seeding takes advantage of this process by introducing additional particles into the clouds, providing more nuclei for water droplets to latch onto and grow. The most common method of cloud seeding involves using specialized aircraft to disperse silver iodide, a compound with a crystalline structure similar to ice, into promising clouds. As the aircraft flies through the target cloud, flares containing silver iodide are ignited, releasing a trail of microscopic particles in their wake. These particles act as artificial ice nuclei, attracting the supercooled water droplets within the cloud and encouraging them to freeze and grow. As the ice crystals grow larger and heavier, they begin to fall, collecting additional moisture as they descend through the cloud. Eventually, if atmospheric conditions are favorable, the ice crystals may melt and reach the ground as raindrops. Alternatively, in colder environments, the seeded clouds may yield an increased amount of snowfall. However, the success of cloud seeding operations depends on a complex interplay of factors, including the type and characteristics of the targeted clouds, the ambient temperature and humidity, and the wind conditions. Not all clouds are suitable for seeding, and even when conditions seem ideal, the results can be unpredictable. Scientists continue to study and refine cloud seeding techniques, seeking to optimize the process and better understand its potential impacts. While cloud seeding has been employed for various purposes, from enhancing snowfall at ski resorts to alleviating drought in arid regions, its effectiveness remains a topic of debate. Examining claims that cloud seeding caused the UAE floods in the wake of the devastating floods that wreaked havoc across the United Arab Emirates, particularly in the bustling city of Dubai, a flurry of speculation emerged on social media platforms. Many users were quick to point fingers, attributing the unprecedented rainfall to the UAE's long-standing cloud seeding program. These claims gained traction rapidly, with videos of the country's rain enhancement efforts circulating widely alongside images of the flooded streets and inundated infrastructure. At first glance, the allegations might seem plausible. After all, the UAE has been at the forefront of cloud seeding research and implementation for years, striving to boost rainfall in the arid nation. The country's meteorological authorities openly acknowledge conducting numerous cloud seeding flights in the days leading up to the torrential downpour. Reports emerged of aircraft dispensing salt flares into the clouds, a common technique used to stimulate precipitation. However, as the claims of cloud seeding's culpability in the floods gained momentum, experts in the field began to push back, offering a more nuanced perspective on the situation. They argued that while cloud seeding can indeed enhance rainfall, it operates on a much smaller scale than what would be required to cause such widespread and catastrophic flooding. The technology, they explained, is designed to coax moisture out of receptive clouds, not to unleash biblical downpours. Meteorologists and climate scientists pointed out that the UAE, like many regions worldwide, was already experiencing a significant weather event prior to the flooding. Radar imagery and forecasting models had detected a massive low-pressure system approaching the area, laden with moisture from the Arabian Sea. This natural phenomenon, they argued, was the primary driver behind the extraordinary rainfall, not the comparatively modest cloud seeding operations. Moreover, experts emphasize that cloud seeding is not an exact science, and its effects can be difficult to predict and quantify. While the UAE's rain enhancement program has yielded positive results in the past, increasing rainfall by an estimated 10 to 30%, it is far from a guaranteed outcome. The success of cloud seeding depends on a complex interplay of atmospheric conditions, including temperature, humidity, and wind patterns, which can vary greatly from one event to another. If not cloud seeding, what did cause the devastating UAE floods? As the floodwaters receded and the cleanup efforts began in the United Arab Emirates, the question on everyone's mind was, if cloud seeding wasn't the main culprit behind the devastating floods, then what was? The answer, according to experts, lies in a complex interplay of factors, with climate change playing a significant role. Scientists have long warned that one of the most profound impacts of a warming world is the increased frequency and intensity of extreme weather events, including heavy rainfall and flooding. As global temperatures rise due to the accumulation of heat-trapping greenhouse gases in the atmosphere, the air's capacity to hold moisture increases. This means that when the conditions are right for precipitation, there is a greater likelihood of intense downpours as the atmosphere releases its enhanced moisture content. In the case of the UAE floods, this climate change-driven phenomenon likely played a crucial role. The region was already experiencing a significant weather event with a moisture-laden low-pressure system bearing down on the area. As this system collided with the warmer, more humid air, it created the perfect conditions for an extreme rainfall event. The result was a flood that overwhelmed the UAE's infrastructure, which is more accustomed to dealing with scarcity than abundance when it comes to water. When heavy rains fall on these surfaces, the water quickly runs off, gathering momentum and volume as it flows towards low-lying areas. The rapid expansion of cities like Dubai, with their vast expanses of impermeable concrete and asphalt, further exacerbates this problem, as the built environment channels water into streets and neighborhoods rather than allowing it to percolate into the ground. The potential drawbacks of an over-reliance on cloud seeding. As nations grapple with the increasingly tangible effects of climate change, the allure of cloud seeding as a potential solution to water scarcity has grown. However, an over-reliance on this technology may come with unintended consequences and potential drawbacks that should not be overlooked. One of the primary concerns surrounding the widespread use of cloud seeding is the possibility of uneven distribution of its benefits. While the technique may increase rainfall in the targeted area, some experts worry that this could come at the expense of downwind regions, potentially depriving them of much-needed precipitation. This robbing Peter to pay Paul scenario could lead to heightened tensions between neighboring countries or states as they compete for limited water resources in an increasingly arid world. There are also questions about the long-term environmental impacts of the chemicals used in cloud seeding, such as silver iodide. Although research suggests that the concentrations of these substances are generally low and unlikely to cause harm, the cumulative effects of their widespread use remain unclear. As cloud seeding becomes more prevalent, it is crucial to monitor and study these potential ecological consequences to ensure that we are not inadvertently causing damage to delicate ecosystems. Moreover, an overemphasis on cloud seeding as a panacea for water shortages may distract from the urgent need for more comprehensive and sustainable water management strategies. While increasing precipitation can certainly help alleviate drought conditions, it does not address the underlying issues of overconsumption, inefficient water use, and inequitable access. By focusing too heavily on technological fixes like cloud seeding, we risk neglecting the important work of promoting conservation, improving infrastructure, and ensuring that water resources are distributed fairly and responsibly. Perhaps most concerning is the potential for cloud seeding to breed complacency in the face of the growing climate crisis. As the world becomes increasingly adept at manipulating the weather, there is a danger that this may create a false sense of security, leading some to believe that we can engineer our way out of the problems created by climate change. However, the reality is that no amount of cloud seeding can reverse the fundamental shifts in temperature, sea level rise, and ecosystem disruption that are already underway. While cloud seeding may have a role to play in mitigating the impacts of climate change, it is crucial that we approach this technology with a critical eye and a commitment to addressing the root causes of our environmental challenges. By recognizing the potential drawbacks of an over-reliance on cloud seeding and embracing a more holistic approach to water management and climate adaptation, we can work towards a more sustainable and resilient future for all. As the debate surrounding the role of cloud seeding in the UAE floods continues, it is clear that the situation is far more complex than initially believed. While the country's rain enhancement efforts may have marginally increased precipitation, it is highly unlikely that they were the primary cause of the devastating downpour. Instead, the fingerprints of climate change are becoming increasingly evident, with rising global temperatures leading to more frequent and intense extreme weather events. As we face the growing challenges posed by a warming world, it is crucial that we heed the warnings of scientists and experts, using the best available knowledge to guide our decision-making and preparedness efforts. Only by working together and embracing a holistic approach can we hope to mitigate the worst impacts of climate change and build a more secure future for generations to come. It's now time to hear from you. Imagine a future where countries engage in weather wars using cloud seeding as a weapon. How do you think this would play out, and what would be the consequences for the world? Let us know in the comments below.